little bit about me. I work at the Web Republic. I've been using Python for a while in different projects. I'm also co-organizer of the Swiss Python Summit, which is kind of like PyCon Switzerland. If you want to attend, hit me up. I also help organize the Swiss Python user. Okay, this is what we are going to cover today. A quick introduction, and then a kind of framework that is going to help you maintain a legacy code base. First, I'd like to know about your experience. Who's been in the software development business for less than a year? Raise your hand.
Less than a year.
Less than a year. Less than 3 years. Between 3 and 6. More than 6. Okay. So we have a mixed audience. Thanks a lot. So why discuss maintenance? If there is a single reason I can tell you for discussing maintenance, it's because it's very costly. It's because there is money on it. You know, we live in a world that appraises innovation, but I mean, you finish a project and then it's not over. Most of the times, somebody needs to maintain it, somebody needs to keep it alive, and then most of the time the cost of maintaining costs up to 80% of the whole project. So that's a lot of money. So, you know, I wanted to get an idea of how much awareness we have in the industry and software maintenance. So, for instance, if you go to Amazon and search for books on computer programming, you get 200,000 results. That's a quite good number. But what happens if you search for software maintenance? That's much less. It's 15,000. Why so? Even more, if you see the results, the first 3 titles look really promising: software maintenance, concept and practice, and so on. But look at the 4th. Would you consider this is a book on software maintenance? HTML and CSS for dummies? Not really. So another way to get ideas on how people perceive software maintenance is Google autocompletion. And then people ask, like, why is software programming easy? Right? And on the other hand, people ask, why is software maintenance difficult, costly? So there's this perception that everything new is nice and everything old is bad. But you know, I wanted to compare how we fare, how we as the IT industry, how we compare against other industries. So for instance, take the car industry. Last time I got a brand new car, I got 5 years warranty. And normally, I don't know, a car can last up to 200,000 kilometers, maybe, like on average that's 11 years. But there are other cars. So, has somebody maintained a system for 11 years? Is somebody here? You? Is it a commercial system? Wow. 11 years, that's something. So, take another instance, the rail industry. You know, I once met this guy. He's working for the Swiss Railway Federal Company. And they have a system that it's basically for the tracks. You know, sometimes trains need to go left, sometimes they need to go right. So there needs to be a system switching directions. And then they have the latest system from Siemens, It's got a short cycle maintenance. It's only 80 years. And then the long-term maintenance cycle is 150. So I don't think there's even a language or a computer that is so long or so old as these systems, right? What do we have in the IT industry? We have the Linux kernel, which is 25 years old. We have LaTeX, which is slightly more than 30 years old. And this is some research I did. There's this system in the US Treasury Department, which has been running for 56 years. Cannot imagine how this is. And there are probably many Fortran or COBOL systems. And then this made me remember about the joke. You know, normally when you hire a programmer, you request, I need 5 years of experience, right? 3 years of experience. But what happens with COBOL programmers? You request 5 years of life expectancy. Because normally they're quite old, right? So, my record keeping a system alive was 4 years. But I would like somebody to tell me he can top it. So you say 11?
I've got 10.
Who's some more?
I've got 10 years.
10?
10.
10. Congratulations. Somebody else? No. How long is PyCon? How old? Like 20 years or so? So, this is my personal view of software maintenance. We have a saying in Mexico, which is winning the raffle of the tiger. You know, a raffle is kind of a lottery, so you buy a ticket. But the point here is that you have the winning ticket, but what can you do with a tiger? Like, it's basically something you don't want, it's dangerous, you prefer not to have won it, but guess what, somebody told you, congratulations, you have to maintain the system. Yeah, it's yours. And that's how I see it. So a little bit about my experience. You know, when I was much younger, back in Mexico, I was fresh out of university. And then, you know, I started programming, maintaining also some programs. And then I noticed some people had really bad quality of code. But, you know, I was young, and then I assumed, well, maybe it's because we are at the third pole, like we're in Mexico. Maybe our education is not so good. I don't know. So I assumed everyone in Mexico was writing bad code because of the pieces of code I was exposed to. Turns out, after a while, I was hired by an American company, and before starting, I was really excited. Like, Jesus, it's gonna be like a first world company. I'm so looking forward to see how nice code they have. Like, you know, they come from Harvard or from, I don't know, these nice universities. And the system I received for maintenance had a core. The core was a class, a Java class, which was 3,000 lines long. And it consisted mainly on a single switch case. So I was really surprised because these guys actually managed to do structured programming in an object-oriented language. And I think that's kind of an achievement. And then I moved to Switzerland. That's where I live. You know, the mindset in this American company was, I don't really care how you do it, just make it work. So the idea was that you work like crazy, typing code, and as soon as it was deployed, it was no one's problem. So I came to Switzerland with that idea in mind that it didn't really matter what you do as long as it was working on production. And that caused me a lot of troubles, actually, because well, there's something that some Swiss are very proud about, and that's the quality of their products. And I had really a lot of discussions, like they told me basically, yeah, I know you want to get things done faster, but this is Switzerland, so please do things as they should. So I assume then, yeah, some people write bad code, but not everyone has to be a bad coder. So that's why I came up with kind of a little framework for doing software maintenance, because I was so pissed off with my previous experiences of doing this. And now I have a motto, I read it somewhere. Basically, the idea is not to fix things, just be proactive. So always code as if the guy who ends up maintaining your code will be a psycho and he knows where you live. But yeah, sometimes we cannot have that. So the first part is understand. You know, we are technical people, and most of the time we love technical details. But the truth is that the source code doesn't live in a void. Normally there is a business reason for it, because people need to make money out of it, because people need to save time with it. So it's not because we don't get a job just because we are good coders. We get our jobs because we are solving somebody's need. And that's something we need to keep in mind. So you need to ask yourself, what's the business case of this product? Because that's going to help you steer your effort. Yeah, you need to understand your users, interview people, power users, create personas, like fake people that you think that they're using your system. If you don't have use cases, then write the use cases. It's never too late. You know, sometimes you take over a system and then you wonder, but why do you have this reverse proxy? Why are there two databases? And you don't know. And that's one of the first things you need to do before touching anything. You need to understand your architecture. Create diagrams, ask people as the team lead, I don't know. You need to know why things are the way they are right now. There's always a reason. Because normally what happens, especially to young people, is that, no, this is junk. I have a better way to do it. And yeah, normally we tend to spoil it. I really like to paint out code. I mean, not every line of my code, but at least important pieces, like critical pieces. Why? Because I don't want to be sitting there in front of the computer all the time, because that's kind of a trap. Sometimes I just print out the code, like 1 or 2 sheets, and then I make notes with colors, with a highlighter, with a pencil. That helps a lot understanding, because this is something you can show to your grandmother, or you can explain it to the rubber duck. Think out of the box. Of course, there needs to be documentation. If there's nothing, write it. Comment the code. And there are good Python tools for this, docstrings, oxygen, Sphinx, and so on. Another good tip is to debug your program, not for the sake of fixing anything. Sometimes you debug not because you want to see where it breaks. You want to debug because you want to see how it behaves, because code has like two views. It's got the static part, but the dynamic part cannot be conveyed just by looking at the code. Sometimes you need to see how the input goes, how the flow goes when it executes. And we have a set of really good Python debuggers, like PDB, PUDB, IPDB, Backyard, WinPDB, and so on. And same goes with the profilers. No, you don't, even if you don't want to fix it, just profile it, just for the sake of it, just for understanding, just to see what kind of bottlenecks you have. And there are good Python tools, cprofile, profile timing, heaping, and profiler, PyCharm, stop. Now you need to break it. Why? Because you need to know the limits of your system, how good or how bad it scales. You know what's breaking. For instance, you may find out that your system breaks with 1 billion concurrent users, but does it actually matter? Are you actually ever going to have 1 billion concurrent users? If you are not, maybe you don't really have to care. But it's good at least to know. And then also to see how would you recover, like what you have like what happens if a node dies and so on. There are then really good Python tools like Nose and PyTest. There are non-Python tools such as Apache Benchmark, Locus, JMeter, or even your own scripts. Does somebody have questions so far? Understanding? No? Let's go in. Second step is build yourself a safety net. Test. That's the goal. Because you want to see the smoke coming out of the computer every time you introduce a bug. So it's important to know which input breaks your system, which input should work all the time in many cases. You need to know, you need to trust your system, right? So we have really good tools as well. Nose, PyTest, Coverage, Selenium, dogs. Now, continuous integration and continuous delivery is a big topic. I haven't gone so far to continuous delivery, but I can only say positive things about continuous integration. Having the neutral build, sometimes, I mean, I think it's happened to every one of us, like the code works in my machine, but not on production. Then that's why we have the neutral build, because it's going to be the authoritative environment. If it works there, we know it's safe for shipping. If it's broken, you better not ship it, right? In our case, for instance, at the Web Republic, we use GitHub protected branches together with Jenkins. So the idea is we have a branch, a Git branch, and if any of the tests breaks, it's not going to let us merge back to master. Because master is kind of the canonical branch. That's the only thing that belongs into production. So anything that's breaking the build is never going to make it into master because we want to let it to be merged. You don't need to use Jenkins. You can use build-out, build-mod, CI, and a number of other solutions like this. Always have monitoring in place. This is really important. You need to know what breaks, especially if it's really unexpected. In my team, we use Upbeat. It's not open source. I think it's commercial, but we really like it. We get reports when a new error comes in. We get statistics how often it's happening. Yeah. Basically, use any tool that helps you be aware of anything that is broken in your system. Of course, we ourselves, we automate other people's job, and that's what we should do with our job as well. We should automate as much as possible. In my case, I'm really bad with provisioning and deployment because I always forget a step or so. So Ansible has saved my life quite a lot of times. But I mean, you don't have to use Ansible. You can use other tools like Salt, Puppet Chef. Questions so far? So we are heading to the last part of the talk. Please bear with me. Now, you understood, you know what you are doing, you know your system, you have a safety net, and it's only now that you have the confidence to make changes. First proposal for me is do as the Boy Scouts. Leave the code cleaner than you found it. Always run bytecode style, which used to be called PEP 8. This is one of my favorite plate 8. It makes a lot of checks from the style. It's really useful. I can only recommend it. And Pilot and Raven, which we are going to see in a second. First one is Raven. I found about it about 2 months ago maybe. It provides you a lot of metrics like lines of code, effective lines of code, cyclomatic complexity, and a couple of others which I don't totally understand yet. So let's discuss cyclomatic complexity. It's really simple, the concept. Basically, the program is going to count 1 every time you have a nested statement. For instance, if you have if you have for, if you have while, every time it finds one of these, the score is going to be increased. So at the end, you get a ranking. I would say from A to C, it's quite acceptable. It's a good goal to have this. Anything in the red area is probably calling for trouble, because it means it's really complex, it's unstable, it's hard to maintain. So if there's a place where you want to start changing, it's probably this, refactoring, getting things a bit more simple. So this is how you run it. Just write on a couple of flags, and then you see, for instance, function. It's got a score of 15, which is kind of acceptable. This class, on the other hand, it's got A, so I feel more confident. So that means if I have a look at this report, if I take over a product, I would probably focus on refactoring this, because I think this is going to bring a lot of gains. I think probably most of you know PyLint. It probably deserves a talk on its own. It's quite a big product. It gives you a lot of feedback on your code, like exceptions and common pitfalls. If you can't use it. In my case, for instance, I took over a Python code base, and the first time I run PyLint, I got like 2,000 warnings and errors. So yeah, you have to fine tune it. It's not easy. You have to configure it. So sometimes, I would like to have like something in place, like something automatic that every time I do a commit, checks and runs PyLint. That would be my ideal environment. But so far, I cannot afford to do it in one of the major products I'm working on, because it's got too many failures. But whenever you can do it, go for it. Also, there's a lot of gain to be made in improving the people. If you can, please do testing development, especially, not on existing code, but the idea is that every new piece of code that you come up with has a test, right? And then if there's a single takeaway from this talk, it should be this: do code reviews. In my experience, this is where the more gains can be made, for several factors. First, sometimes when you know that no one is going to review your code, then you can slip in like nasty hacks, like quick fixes, and then you say, well, I'm going to fix it later. But no, you're never going to fix it, actually. And then with this approach, somebody's going to read it. And if it looks wrong for you, it's going to look wrong for your teammates. So your reputation is at risk with every commit. Does somebody remember these devices, these gadgets? They were fast. I remember, I've been in the industry for a while, so I remember some pads, like enterprise Java beans. Did somebody use those? Java applets, CGI, aspect-oriented programming. Does somebody remember any of this? They were like really big deal, like everyone wanted to learn that. And people spent months learning this, like visual programming, big data, I cannot say. It's up to discussion because it's still ongoing. And people spend a lot of effort, resources learning this, just to find out that in 2 or 3 years, this was gone. And this is not going to be the case with code reviews, because they've been here for like 40 years already. They're not going to go away. If you learn how to do them in Python, you can use them in any other technology. Yeah. Does somebody know what the boss factor is?
It's how many people you need to kill a product.
Exactly.
How many people need to build one processes.
Yeah, so if you have a team of 10 people, and then boss runs over 5, if you have a high boss factor, then it's really bad, right? Because it can be fatal for your product. But on the other hand, if you have a really good boss factor, that means that if 9 people gets, I don't know, they get fired or they go away, they get sick, if there is 1 person remaining, it means this person is still going to be able to keep the product alive, and then he or she is going to be able to train other people to take over. So code reviews help with this, because for instance, everyone benefits from them, because beginners know, they learn a lot from the experienced developers, because they found new ways of doing things, like looking at other people's code is usually a good way of learning. Also, the experienced people get something, because I mean, you can only cover certain parts of the whole platform you're working on. So if somebody else is working on a small part, even if it's really small, even if it's really simple, if you get to review a junior's code, you know what's going on, you know what kind of bugs he can potentially introduce. So it's good for everyone. I can only attest that this is increasing the quality of software. Basically, the idea is the longer it takes you to find a bug, the more expensive it is to fix it. So if you fix it here, it's really cheap in design. But if you fix it once it's made into maintenance, it can be up to 100 times more expensive to correct. So I can totally recommend this approach. How we do it at the Web Republic, we have a little script which matches couples. So that means for the whole week, one of us is going to review the other's code and vice versa. So we are a couple or code review buddies for a week. Yeah, it's really simple. You know, at the beginning we were a bit skeptical, and I've given this talk somewhere else, and then people were asking, but you know, I feel we're going to spend too much time there. I don't think this is really worth. I think my manager is going to laugh at me, because he's going to say, no, you're not writing any code, so that's useless. Well, what we did is we started with a 50% goal for code review. That means every week somebody was reviewing other people's code, but not vice versa. So, I mean, I think we even started with 25%, but we saw it working, it was really good. So at some point we decided to go for 100%. Every piece of code that makes it into the repository, gets reviewed, needs to be approved. It's really easy, we do it with GitHub, just branch. And once you've done the branch, people comment about this, they give input, and then once it's approved, then you match back, and that's how it works. A couple of rules about code review. It's not personal. You're not reviewing your colleagues. It's the code who's on the review. So whenever you make a comment, you don't say, hey, you did this and it was really bad, it was wrong. No. Normally the approach is, have you considered to do it in a different way? Or can you please explain why this is going to work the way you expect it to. A couple of basic rules as well. Try to solve in a timely manner. Like if somebody opens a pull request, just maybe you just want to type AC key, just like the internet protocol, and maybe give them or give her an estimate. I'm gonna have it ready tomorrow, today, AC key, the week or so. Normally, try not to take too little, and especially try not to take too much, because if you submit like a really big pull request, people get tired. They're gonna lose the overview of the whole thing, and then chances are that you let things pass that otherwise could be detected. Don't overwrite other people's code. Don't tell them like, no, you know, this is really bad. Just let me rewrite it myself. You need to provide feedback, and you need to let people do it themselves. And there are really good checklists like style guidelines and so on. You know, I consider code reviews are just like washing your hands after going to the toilet. It's something very simple. It's something everyone should do, and it takes only a single person not doing it for things to become filthy and dirty. That's it. Thanks a lot. Somebody have questions?
How much time do you spend on the largest code review? 100 lines.
So how much time do you spend on 400 lines of code review?
Well, now we know how it works, so 100, it could be like 10 minutes maximum, and then the fixes, so it's not really a lot.
So do you check out the code and debug it?
No, we do it via GitHub. GitHub has several tools for it. Just go to the website, to your repository, and then once you open the pull request, you see they have a really nice workflow. Anybody else? No? Thanks a lot. I'm going to be around. If somebody wants to discuss the topic, please approach me. If anyone is interested in speaking in the Swiss Python Summit, also approach me. Thanks.